Possible Industries, and we are presenting our capstone project. I'm Mona.
I'm Daniel.
I'm Ian.
I'm Tyler.
In the Materials and Fluids Lab, there is a noisy fatigue testing machine which exposes the students, teaching assistants, and professors to damaging levels of noise. Our client, Dr. Topoleski, has asked us to solve this issue, which the group will achieve by creating a sound-reducing chamber with an added LED indicator to alert the user when a test is complete. Our mission scenario diagram details the steps required to use the system from start to end. It starts with the green box where the sound-reducing chamber is placed over the fatigue machine, which is where it will remain as the fatigue machine is being used. The yellow box shows the chamber will only be removed for any major maintenance.
Our mission scenario diagram, as well as Dr. Topoleski's request, allow us to create our system requirements. So we have our user input where the chamber is opened and the fatigue machine is allowed to be set up. From there, two things happen. First, the fatigue machine outputs a noise level, and that's where our sound dampening material, the denim fiber insulation, is used to reduce the level to 50 decibels or less, as well as reduce the frequency output. The second thing that happens is the specimen fractures. That's where our laser sensor comes into play. That will indicate the user when the fatigue test is complete. Our design evolution is shown in figures 2, 3, and 4. In figure 2, we originally had the front panel flipping out and over on top of the lid, but that posed a risk to students walking in the aisleways. Figure 4 shows the combined evolution of all of our designs, where the front panel flips up and over and rests against the wall. That gives students, TAs, and professors full access to the top and front of the fatigue machine. In our final CAD model, we have the insulation as well as the LED indicator shown in figures 5 and 6.
So after designing the CAD model, we performed an acoustic analysis simulation using ANSYS. As you can see in figure 7 on the left, that is the finite element analysis showing the sound pressure level distribution. The areas in green and yellow are areas of higher sound level, and towards the sides of the chamber is the lower sound levels seen by the bluish regions. And the average of this overall sound pressure level distribution is around 43 decibels, which is below our average or below our system requirement. We then went to plot the sound pressure level versus frequency, and we determined that it is below our system requirement at frequencies below 550 hertz.
Figure 9 shows the final schematic for the laser sensor signal, where an Arduino powered chip will handle a laser pointed at a sensor. The mechanical arm located inside the fatigue machine that normally indicates when testing is done would drop down and interrupt the signal from the laser to the sensor. This interruption will trigger a response in the Arduino that turns on the external LED light bulb, basically adding an external and extra way to let users know the fatigue testing is done. This concludes the presentation of Possible Industries.